All right, let's jump right in. We're going to talk about a quiet revolution that's totally changing how we build, well, everything. Think jumbo jets, think race cars. This is all about materials that are stronger, lighter, and just plain better than anything we've had before.
Okay, so take a look at this. Imagine you have to build a giant airplane. What sounds better? Sticking together thousands of metal sheets with something like 50,000 little fasteners? Or what if you could just make the whole thing in one single giant piece? That exact question right there is what this whole composite revolution is about.
And this next number, this is really why it all matters. 50%. 50%. Think about that. Half the weight of a brand new Boeing 787 Dreamliner is made of these advanced composite materials. That's not a small change. It's a massive, staggering shift away from old school metal.
So, yeah, what's behind this huge change? Let's dig into why everyone, from plane makers to car companies, is betting so big on these materials. It really all boils down to one key idea. And you're going to hear this phrase a lot: strength to weight ratio. Basically, composites give you all this amazing strength and stiffness, but they're super light. You don't have that weight penalty you get with steel or aluminum. It's like a featherweight boxer who hits like a heavyweight. They totally punch above their weight class.
So what even is a composite material? Well, the basic idea is actually ancient, and it's beautifully simple. It's just some things are stronger when you put them together.
Okay, here's the more official textbook definition. You're basically taking two or more totally different materials, you combine them, and what you get is way better than what you started with. The new supermaterial has abilities that neither of the original parts could ever have on their own. And like I said, this is not some brand new idea. I mean, we're talking way back, 4000 BC. Ancient builders already knew that if you mixed straw into your clay, you got much, much stronger bricks. Fast forward to the 1800s, we started doing the same thing with concrete, putting steel rods, rebar, inside it. It was really only in the 1970s that we got to the advanced stuff, the high-tech composites that are really changing the game today.
So let's just stick with that ancient brick example for a second. Think about it. By themselves, the ingredients aren't that great. Straw? Super weak. You can't build anything with it. And a brick of just pure clay? Yeah, it's really brittle. It'll just crack and fall apart super easily.
But put them together and it's like magic. See, the clay is great at not being squished. That's called compressive strength. The straw, on the other hand, is great at not being pulled apart. That's tensile strength. So when a little crack starts to form in that brittle clay, it immediately runs into a piece of tough straw, which stops it dead in its tracks and spreads out the force. It's the perfect example of the main idea. You combine materials so they cover for each other's weak spots. Okay, so let's fast forward to today's world. Obviously, we're not using straw and clay anymore. In modern, high-tech composites, we have two main players. You've got the fiber and the matrix. So here on the left, you're looking at these bundles of reinforcing fibers, super magnified. They might just look like threads, but don't let that fool you. They're unbelievably strong. Then, over on the right, you see what happens when you put it all together. Those same fibers are now embedded inside the matrix, which is the stuff that holds everything in place. And each of these two parts has a very specific job to do. The fibers, they're the backbone, the superstars of the team. They bring all the strength and the stiffness. Then you have the matrix. You can think of it as the glue or the support system. Its whole job is to hold those super strong fibers exactly where they need to be, protect them from getting damaged, and make sure that any force or stress gets spread out evenly across all of them. It's really a perfect partnership right down at the microscopic level. And what's cool is that engineers have this whole menu of fibers they can pick from, depending on what they're building. You've got glass fiber. That's probably the most common and cheapest. You see it in things like boat hulls. Then you have the famous one, carbon fiber. That's the star player for race bikes and supercars because it's so incredibly strong and light. And then for something like body armor, you need special fibers called aramids. Kevlar is the one you've probably heard of, and they're amazing at resisting impact.
So, okay, does this really make that big of a difference? Well, yeah. Let's put it into perspective. We all know steel is strong, right? But it's also super heavy. Now imagine a part made from carbon fiber composite. That part can actually be stronger than the same part made of steel while weighing just a tiny fraction of it. I mean, that's not just an improvement, that's a total game changer for anyone designing, anything. And hey, this isn't just stuff for spaceships and million-dollar supercars. Once you know what you're looking for, you'll start to realize that composites are kind of everywhere. Let's check out a few places you might see them in the real world.
Take high-performance cars, for example. We're talking about parts like brake calipers being made from composites. Instead of using heavy old cast iron, they use a special aluminum matrix composite. And boom, you've just cut the weight of that part by half. And why does that matter? Well, lighter parts mean the car handles better, it accelerates faster, and it even gets better gas mileage. It's a win-win-win.
And here's where it gets really serious. Personal protection. The life-saving power of composites is just undeniable here. Think about body armor. It's made of layers of woven fibers, like Kevlar. They're designed to literally catch a projectile, to deform it, and to spread out that massive amount of impact energy across the entire vest so it doesn't punch through. It is just a perfect real-world example of how these fibers and a flexible matrix can work together to do incredible things. And of course, there's the world of sports, which composites have totally revolutionized. I mean, if you've ever held a modern tennis racket, a golf club, or a high-end bicycle, you know what I'm talking about. They're so strong, so stiff, and yet they feel like they weigh almost nothing. That's because of materials like carbon fiber. And that lets athletes swing faster, pedal harder, basically push the known limits of human performance.
So, okay, the benefits are pretty clear, right? And the applications are popping up all over the place. But the key thing to realize is that this isn't just some passing fad. The trend is crystal clear. Major industries are using more and more and more composites, and it's not slowing down.
And you know what? Nothing shows this trend better than looking at commercial airplanes. Just look at the history of Boeing's big jets. Back in the 80s, their 767 was maybe 5% composite material. Then came the 777 in the 90s, and that jumped up to around 12%. And then the 787 Dreamliner. It made this absolutely incredible leap all the way to 50%. I mean, look at that chart. The trend could not be more obvious. So, there you have it. This incredibly simple idea, just combining different materials to make something better, has taken us all the way from ancient mud huts to the absolute cutting edge of aerospace. These materials are completely rewriting the rules of what we thought was possible, which leaves us with just one big question, right? What are we going to build with them next?